Assalamu alaikum dear students. Today we are going to discuss one of the most important topic of this mathematics, or simply we can say that the pure mathematics, which is relation. Now in order to discuss relation we will use the previous concepts or the concepts which we already discussed, which first one is called Cartesian product and the second one is if A is the set with n elements, means the cardinality of A is n, then the number of subsets of this finite set is 2 to the power n. So this means that it has 2 raised to the power n different subsets. Now let me consider two different sets, set A equals to 1 2 and set B equals to AB. Then by definition of Cartesian product you know that it is simply A cross B equals to 1A 1B 2A and 2B. So this n cross A means Cartesian product A cross B has 4 elements, that is n of A cross B is 4. So the number of subsets of this very set A cross B is 2 to the power 4. By the above concept it is simply 16. Now let us denote these all 16 subsets by RIs, that is R0, R1, R2 up to R15. These are different, or these are the all different subsets of this A cross B. That is R0 is null set, R1 is 1A because it contains only one element, R2 is 1B, similarly up to R6 is 1A 1B, R7 is 1A 2B. Similarly let me consider R10 to be A cross B because every set is subset of itself, which is the improper subset, and the rest or the remaining are proper subsets. Now let we consider only two subsets of among these 16 subsets. Now here R6, one is 1A 1B, that is R6, and the second one is R7, that is 1A 2A, because these are the two different subsets of this A cross B. Now in R6, set of first entries is 1A 1B 1 1, because this R6 contains two different ordered pairs 1A 1B, and in these two ordered pairs the set of first entries is 1 1. In sets we can simply write this as singleton set 1. So clearly this 1 is subset of first set, that is set A. Similarly in this R7, set of first entries, here it is first entries, equals to 1 and 2, because this R7 contains two ordered pairs 1A and 2A. This means that set of first entries is 1 2, set 1 2, which is simply A. So in R6 set of first entries is subset of A, and in R7 set of first entries is simply a set A. Similarly in this R6 set of second entries, because second entries means in ordered pairs are A and B, so it is simply set B. Similarly in R7 set of second entries is AA, this means singleton set A means subset of second set, that is set B, because second entries are from the second set of A cross B, that is from set B. So we have here two different situations, or simply two subsets. These subsets we can represent visually as, or we can give them the representation as this set of first entries in R6 is 1, and the set of second entries in R6 is AB, that is AB. In R6 we have ordered pair 1A, so this means that this 1 is connected with A. Similarly this 1 is connected with B in R6. In R7 we have two ordered pairs, set of first entries is 1 2, because here we calculated this, it is 1 2. Set of second entries is simply a singleton set A. Here in R7 there are two ordered pairs 1A, this means that 1 is connected with A, that is 1 is connected with A under this R7, 2 is connected with this A. So simply we can say that this subset of, or any subset of A cross B, this gives us the connection between the elements of A with the elements of B, or simply it gives us the connection between set A and set B. So this very connection is simply called as the relation from A to B, from A to B. So what is simply a relation between, because relation simply in English, relation simply means connection between two entities or connection between the two objects. Here we have connection between the two sets. That is why this subset is simply called as the relation from A to B. So if we consider any subset of A cross B, it gives us the connection or the relation between the elements of A with the elements of B, or simply with the elements of A with the elements of B. So how can we define the relation in general? So the definition here is a relation, or suppose we will define that relation by or, from a non-empty set A to B. So we have two different non-empty sets here, A and B, is simply a subset of A cross B, because in this we find that the any subset of A cross B actually gives us the relations or the connections between the elements of A with the elements of B. So the relation from A to B, non-empty set B, is simply a subset of A cross B. So if or is the relation, if or is the subset of A cross B, then we say that this or is actually subset of A cross B. Then we can simply say that or is the relation from A to B. So any subset, here or is in general subset of A cross B, is simply a relation from A to B. Or second definition is a relation or from A to B is a rule. It is a rule which associates elements of A with the elements of B. Here rule means the subset. Like we consider R6 and R7. In R6 and R7, in R6 we consider two elements, 1A and 1B. So this means that this is the rule because of which we consider only two elements from those four elements of A cross B. So simply it is a rule which associates elements of A with the elements of B. If R is the subset of A cross B, and when it is a subset of A cross B, this means that it contains its elements are ordered pairs. Now let me consider AB is the ordered pair which belongs to the relation or. When AB belongs to or, this means that A is related with B under this relation or, and we simply write A or B, that is A is related with B under this relation or. Here set of first entries of or is called as the domain of the relation. Like in R6 we consider 1 as the set of first entries, so 1 is the domain, and set of second entries of or is called as the range of relation. So the range of relation is always subset of second set, that is set B, while as domain is always subset of first set, that is set A. So domain is subset of A, range is subset of B. This set B, whole set B in a relation, is called as the codomain of the relation. Like if we consider here in a relation R6, set of first entries is 1, so the domain of this very R6 is singleton set 1. Range is second entries means A, B means set B, while as codomain is set B. So we can here simply say that this codomain or the range is always subset of codomain. Sometimes range may be equals to codomain, sometimes range may be proper subset of domain. So inshallah in tomorrow's video lecture we will discuss this very topic again. So thank you.